Okay, we're almost there, right? Question 2, part F. We're going to wrap this up here. So in part F, we're asked to take the limit as x goes to 0 of 2 to the power of x plus sine of x over x to the 4. Now, as usual, we'll want to go ahead and do direct substitution, plug in 0, see if we get an indeterminate form that requires us to do more work. 2 to the 0 is 1. Sine of 0 is 0, right? We got to go back to our unit circle. Sine of 0 is 0. Divided by 0 to the 4 would be 0. So what I notice is I'm getting 1 over 0. Okay, this means that I'm going to be pushing towards infinity, but the question is, am I going towards positive infinity? Am I going towards negative infinity? What is happening, right? So again, just as we did in part E, we're going to go ahead and analyze both sides, right? Because this is assuming it's a two-sided limit. So I'm going to take 0 as I approach from the left side, and I'm going to repeat the same process as I go to 0 from the right side, right? Left side, right side, see what we get. Now, let's analyze our pieces here. So if I go from the left side, 2 to the power of 0 is going to be 1, right? Anything to the power of 0 is going to be 1. Now we can try and talk about, is it going to be bigger than 1, less than 1? I'm just going to call it 1, right? So 1 is 1 is 1, whether it's like 0.999 repeated or it's 1.0001. Conceptually, to me, those are basically 1, right? I don't really care about that. Now, sine of 0, again, from the left or from the right side, sine as I go towards 0 is still going to 0, right? If you were to plug in essentially 0, sine of 0 would be 0. So again, that is going to kind of disappear. Maybe you want to think of it as a slightly bit negative number or a slightly bit positive number, right? We don't really have to do that analysis because I'm just going towards 1, right? That's not going to change my answer. 1 is going to be 1, whether I'm adding a really small value or I'm subtracting a really small value, okay? Now on the bottom, this is going to be the main focus, right? So the top is going to be some positive 1, right? But on the bottom, if I went towards 0 from the left, I would be plugging in a number that's slightly bit negative, conceptually, if I were trying to do like a substitution, right? Or look at this on a table. And if you take a number that's a slight bit negative and you raised it to the power of 4, an even power, it would turn positive, right? We know raising any number to a even power would turn it positive, right? So this would end up being in the denominator as 0, but it would be a slightly positive 0, right? 0 from the positive direction. And so what that means is we end up getting a positive infinity, right? So positive infinity. Then we do the same thing as I go 0 to 0 from the right side. When I plug in 0 from the right, 2 to the 0 is still 1. Again, if we want to mess around with that, we can, but I'll just call it 1. Sine of 0, still 0. Divided by, now, no matter what, we just established raising something to the power of 4 will always give me a positive outcome. So no matter if I plugged in 0 from the left or 0 from the right, I didn't really care because the outcome was still going to be a positive. Therefore, positive over positive would be a positive, and then a number 1 over 0 pushes to infinity, as we discussed. So therefore, we notice that the limit as I go to 0, two-sided, of 2 to the x plus sine of x over x to the 4 would equal positive infinity, right? Because both the left and the right side limits are equal to each other. Perfect. Okay, so we've gone ahead and gone through all of our limit questions for our question 2. If you missed any of those or you want to review some of the other ones, feel free to look at some of the previous videos.